We're at the IAS meeting. We're here with Sharon Lewin, who's at Dougherty Institute, University of Melbourne. And we appreciate you taking the time away from the conference because it's been, I used to say a 3-ring circus, I've been a 30-ring circus this year. So much information, and you are focused largely at the cure, research. And we wanted to tell a little bit about your broader perspective over the years, how we're going through this process of cure research.
Yeah, everyone wants a cure for HIV. We have fantastic treatments, but they're lifelong, toxicities and cost, and I think it is still the holy grail of research. And over the last 5 to 10 years, there's really been an accelerated effort as we've had better treatments available and increasing awareness of the need for a cure. And it's a tough area, but I think there's been some significant advances over that period of time, over the last 5 to 10 years. And we've heard a lot about that here at the conference today. A lot of the research is still at the level of understanding where the virus hides, what aspects of the immune systems are important for control, identifying rare patients who seem to be able to control the virus off ART. But we have also moved into some really interesting small interventional studies, and they also can tell us a lot about what strategies might work.
If you had to guess what would ultimately end up as a cure concept, would you believe it would be it would certainly wouldn't be only immunologic, but virologic? Could it be a combination of both? Is that a fair question? Or?
Yeah, I think if I was to guess, and I hesitate to do that because science can often completely surprise you, something out there comes out. Right. I doubt we're going to have a single bullet, meaning another tablet that will cure HIV.
Multivalent vaccination?
Yeah, I think it's the real problem with the real challenge, I guess, in achieving remission. So first of all, what we're aiming at here is remission, meaning that people can safely stop ART, but their virus remains at low levels.
For an extended period of time, or if not forever, for an extended period of time.
Exactly, extended period of time associated with no transmission and no adverse effects of the virus. So, and that's quite different to a complete cure where we just eliminate every last virus that's there. So if we're talking about remission, the people that can go into remission, and we know it's possible, about 1% of people naturally control the virus, keep the viral low levels, less than 50 copies per mil, and a less clear number, but certainly a real number of people also are able to do this after a short period on antiretroviral therapy. And most of the work to date of people in remission and also monkey models in remission points to the immune system playing a really important role. But it's a combination between good immune response and very small amounts of virus. So I think we still have to be tackling both. A strategy to reduce the amount of virus that persists on treatment. We certainly know early treatment does that. You know, transplantation does that, though transplantation's not an option for an intervention. And then, you know, there's other ways we need to explore, because most people are treated during chronic infection after a prolonged period of time of being infected. They won't have that advantage of what early treatment delivers people. So it will be a combination of reducing what's left, what virus is left, and at the same time beefing up the immune system to keep whatever's there under control. And there's a whole lot of new ways that people are looking at on the immune side.
I want to ask you a question which is out of left field here, but I think it's important for the community because we've been all now saying standard of care is to be treated right away. From this perspective of the science, as you know, how the virus seeds every cell in your body, every part of your body, it's over time. Does it not make sense if you were, with what you know, if you were infected today, you would say, I want to be on treatment right away, and tell us why?
I have no doubts about that. I think treatment is good for everyone, and treatment has enormous benefits for people who are diagnosed after many years of being infected. But if I had the choice, yes, I'd want to be on treatment as early as possible. And there's sort of 3 main reasons for that. First of all, being on treatment blocks transmission. So as soon as you're on treatment, you're no longer infectious. And most people really want that. Second, early treatment does reduce the amount of virus that's able to sneak into its hiding places. and it's quite significant. It can be 10 to 100 less virus sitting inside hiding spots in the immune system, hiding spots probably in the brain and other places. And the third thing is that early treatment keeps your immune system in better shape. Treatment does dramatically improve someone's immune system compared to no treatment, but early treatment's even better. There's less immune activation, there's less chance for the virus to start making mutations, and your immune cells are in better shape if you treat earlier. And does that make a difference in the long term on survival? I don't think so, but it will make a bit difference in any cure strategies, that you're starting off ahead of the game if you manage to have the benefit of early treatment.
I think the only thing we used to worry about in the old days is the treatments themselves were so hard to do.
Yeah.
So they said, well, let's forestall using those treatments for a long time. But now with the treatments that are so efficacious and beneficial.
Very minimal. At the moment, what we see is minimal side effects, often easy to take, one tablet a day. I think the benefit has 100% swung to treat early, treat hard. What they were saying many years ago, but now it's much easier to implement.
We have for some time been working on the cure in concert with people from the cancer field, because there's this connection. Is that still a lot? Are we bringing more people from the cancer field to do collaborations? Because I think that was a focus at the pre-meeting.
Yeah, it's a great question, because we had a meeting over the weekend before the start of the conference that was specifically trying to get those two fields talking. We had of the participants, about a third were from the cancer field, about 2/3 from the HIV field. And we talked about a whole range of new treatments that are available in cancer and how they might impact on HIV. And those main areas are, first of all, in the areas of gene therapy. I mean, gene therapy is already under investigations in HIV. That's when you gene edit or remove the gene, or CCR5 gene, so that cells are resistant to HIV. Those techniques have come from the cancer field. But there's new gene therapy strategies where you can build a better immune system with gene therapy. The other big advance in cancer over the last few years has been in drugs that boost the immune system, not drugs that just poison the cancer. And the drugs that boost the immune system may well play a role in HIV, though those studies haven't yet started. And the last thing that we talked about quite a bit is that people who are living with HIV now live long and healthy lives, but there is still increased rates of cancer in people living with HIV. And often people living with HIV and cancer don't have access to the latest treatments because they've been excluded from studies because they're HIV infected. So there's quite a lot of discussion about how we might change that. People with HIV, the HIV is not causing a problem, the cancer is their biggest problem. And I feel very strongly that they should be able to access the latest treatments just like anyone living without HIV.
So that's another point. I know that every doctor says, I've heard doctors say, well, I'm not an activist doctor. I think all doctors are activist doctors.
Yeah, in this area they are.
You step into it.
You're an advocate for your patients.
You're there, right, exactly. But we appreciate the work that you've done, and you're kind of a leader in the field. There's a number of you that are shining stars of the work that's being, to kind of get a better grasp of the work that's being done. And also, the other thing is collaboration. We talked about cancer and the fields collaborating, but there's people that are collaborating, organizations are collaborating, collaboratories are collaborating, and then we also have industry that's collaborating. And of course, the regulators are trying to figure out how we're going to do the research. So it's a giant monster that we built to answer how we move down the road of the cure research. So it's.
I mean, one other really important area of collaboration that might be just worth pointing out is the collaboration between the vaccine field and the cure field. The two biggest challenges at the moment in HIV research is developing a cure and developing a vaccine. But all the hard work that's been and investment in vaccine research is now really helping some of the strategies on cure. So we've heard here at this meeting what role broadly neutralizing antibodies can play in cure. Certainly some interesting results still in monkeys of vaccines that can lead to cure. and other ways to manipulate the immune system that really come out of the vaccine field.
It's amazing that HIV has happened at this point in time in history, because if it had happened 20 or 30 years before it happened, we might not have had that technology and that science.
Yeah.
Because we've had a lot more people that would have died. I mean, look at where we moved in accessing treatment for people in Africa, which is where a large number of the population is living with HIV. So it's exciting that we are here, and genomics is coming along, and like you said, so it's all right at the right moment that we're actually, I guess, moving the field along.
Yeah. I mean, the issues around the monster of collaboration really worked well for the very early days of developing antivirals. I mean, I often talk about why was scientific progress so fast 20 odd years ago in developing antivirals, and that was a major collaboration between academia, industry, clinicians, activists being key. And that model is one that we need still for cure, we need it still for vaccine, and we need it still for implementation, I think.
I really appreciate you taking the time with us. It's been exciting, and it's always a pleasure to understand science from people who are in the thick of it.
Great. Thank you. Pleasure to be here.
Thank you very much.